Hello, this is Timuchin Özger. Welcome to another studio-oriented tutorial. This one is called Nebula. Also, this one is a little bit strange one because COVID-19 is going all around the world, so pretty much everybody's quarantined at home. So this one goes down with the tutorial as a side note. So in this tutorial, I want to explain in Houdini what volume procedurals are. I think they're very underused. However, they're very strong in terms of creating very high detailed volumes. In this case, they're actually geometry shaders. So I want to explain this feature of Houdini a little bit. While we are working on how the CVEX volume procedure works, obviously we're going to apply that technique to something usable. So one of the best things, like I guess we can Google some here, which you should be seeing on your screen as well, is that these amazing images of nebulas. They're basically huge amount of gas, just hanging in space, and they have incredible amount of detail. Like as you get close up and closer and closer, as far as I mean, you can take the pictures of course. But they are extraordinary celestial things, and they are really magical. So I made this little video using this CVEX wax technique, so that I'm going to show you now. As you can see, the strong side of CVEX procedurals is because they are evaluated pretty much render time. So even if you have something really low res, and you just fly through it, and it's going to keep adding more and more detail based on some algorithms. So let's close this. Actually, I think you can see it here as well, because I did put it on the on my website. Just let it load. So as you guys can see, I'm going to zoom in here. We're going to walk through all of this. So this is like a default sphere that is converted into a volume. Just using the exact same values, we render it with X, and then just adding some noise to it, and then adding some, just increasing the frequency of this noise, and then I'm just moving the camera right next to it, and it's like there's incredible amount of detail. Instead of this is not like it's not voxel dependent almost. So and these are some of the images that we will end up making. There is also one. It's not a disadvantage, but it's this technique is at the moment limited to Houdini to Mantra. So I don't think any other renderer at the moment can do this unless you write your own procedural workflow. And also, since I mentioned that we are under quarantine, so I only have one monitor. So instead of creating the nodes one by one, I'm just going to explain them very slowly while I already have them created in my scene. So let's start with Houdini project. First, we're going to go through a very simple sphere. So I just created a geometry here called Vex Volume Procedural Intro, and just create a camera called test cam. Here, let's pull this back up, because no, actually I key this the first frame and the second frame just to render those volumetric spheres. Let's go inside. So it's just an ordinary sphere that has a frequency of 1 meter. And then let's drop in as VDB from polygons node to convert this to volume. And I'm just going to actually increase the resolution, decrease the resolution by increasing the voxel size. If you do a middle mouse, so it's like 35,000 voxels. And what am I going to do next is that I'm going to save this. Okay, so drop in a file cache node, as we do here, and you only need one frame at this moment. So save current frame, and just save it to under geo simple test.bgeo. So wax procedurals we need to create, it needs either gradient or, so we need to be able to tell the renderer in which direction we want the detail to be added, right? So we need a vector. In that case, we can use, if we want to use based on the density, like wherever is dense versus where is less dense, we can use VDB analysis to create a gradient out of this, but I would probably create a new one called gradient. Sorry, gradient. Okay. So if I do middle mouse here, now there's like a gradient calculated out of this volume, but right now we're just going to use, I'm just going to create another one called color, and the density, the distance we're going to use in the actual nebula, but now with the simplistic one, I just want to create my vectors in the Vex procedural shader as well. So let's continue. So I just created another volume here called, basically I just renamed this one, and I named it the color. Actually, well, this is not very correct. It's a float. Should never, doesn't matter, we'll continue. So now I have two volumes here. So I have a density and color, but this is, I probably made a mistake here, so I'm gonna we'll fix it on the way. All right. So, and let's go here because this part I need to plug in after to show you what I'm gonna do with it. So then the next thing is, I'm going to put a volume up, but this volume up is a bit special because it's by default, the volume ups, or any up basically, points to itself, myself. But now we're changing to the shop, and we're pointing it to another structure here. So let's drop in a shop network, like I did here, and I just rename it to Vex procedural, and let's dive inside. So I have two more nodes here. So the first one is Vex volume procedural. So this is when Mantra will know how it should interact with this geometry object. And in the main section, I didn't change anything. In the bound section, though, I changed the sub bounds to specified by sub's bounding box. So that means, in this case, this guy. So basically, it's like how much of this you want to render. Like these are my bounds. Don't render anything out of the bounds. And then I dropped in another node called CVEX Shader Builder. We dive inside. So we have some few nodes here. We're thinking, okay, what is all this stuff? This is basically now reading this file that we wrote out, simple test, and then it's doing something to it, adding noise, displacing its voxel positions, and then outputting a new density. Oh, I guess the color, it shouldn't have worked here, but I guess it worked. All right, so, but this one I'm going to do right under here, again, so to make sure that we know what we're doing. So let's drop in, let's go back up. So because, actually, by default, this will be like this. So if I open this, it will be empty, so let me put one. CVEX Shader Builder, it's called. If I dive inside, as you guys can see, it's empty. So let's do this one now, but let's point, because we're making a new one, for the sake of tutorial, let's put it to 2. And I'm just going to check how long I have been recording as well, because I have one monitor, so I cannot really follow. Where is the time? I don't see the time. Oh, 10 minutes, that's fine. Alright, so now we are pointing to what CVEX to. So if I now visualize this, it's not going to do anything. It's just going to like show me what's this doing here. So we're going to overwrite that information. But sometimes, I think it gets stuck. I may have to open a ticket. So I'm going to open a new Houdini just to make sure that it's doing the right thing. So we're going to dive inside. So I'm going to put a global volume of global parameters. Okay, and then I'm going to put another one called volume of output. So this is our default, basically, CVEX shader that comes out, but at least this is how I started using it. So let me save this other scene. I want to open this up because sometimes it doesn't update properly. Just wait for it to cook a little bit. Oh, maybe that's because I also need to point this at this guy. Okay, let's close the other one. Okay, I'm gonna dive inside here. Okay, so this looks all right. So basically, this volume mode, by the way, is empty. So it's what it's doing is it's literally saying don't process me, but process the shader instead. So this is gonna be CVEX2, right? So let's delete this other guy. Just want to make sure it's correct. So I'm gonna pin this, go inside here and drag and drop. Yeah, we're good. Okay, let's go inside. So now let's start building our very simple volume displacement. So what I can do, or what I did this in here is, remember we cached out the, where is it? Here, this guy, right? We cached this out. So what I'm going to do is I'm going to get this path. So I need to be able to tell Mantra to read some kind of position so we can play with it. So which is just a sphere now. So I'll start by dropping a volume sample. So I'm going to say check against this my scene position, middle mouse promote, and paste. So then I'm going to say based on this output density. So just to check if this is working, let's put a multiply constant to density. And if we decrease this value, as you can see, our scene is updating, so which means that our shader is actually working right now. But I know that sometimes, like, because we could be using the simulation to drive these shapes as well, and sometimes it can be heavy. So the way to utilize this the best way is that I created this little section. Is basically I created a VDB, and I said, okay, I want my VDB to be 0.1 resolution, and then you create a little box here that says that's going to define our bounding box of our volume box, and then let's drop in a VDB activate and change it to reference, so it reads the dimensions from box 1. So basically it reads the dimensions from box 1, and it reads the resolution and the name from the left side. And if I do a middle mouse here, I have a density, very, very low resolution, so I can now put a switch here to show you how to test it. So if I go 1, so basically now I'm only going to see the result of this volume on this edge. But right now, which means because like this you can concentrate the amount of voxels into a lot smaller section. So like this you can get a lot more definition visible. So let's move this a little bit here. Okay, so if I make this bigger, you'll see. Like the bigger you make, you will be spreading the you will be increasing the voxel amount. So the system is going to get like hogged. So you just need to get a little section to understand if your rig is working or not, and then you can go further from there. So right now we have it's going to be still fairly fast, but let's continue editing our shader. So now I'm going to, let's say, do 10, so my density went just cranked up a lot. Okay, so this is our edge, I guess. So let's go back inside the CVEX1. So what I'm doing here is, at the moment, we're not doing anything, just the density is here. So right now we are just sampling the volume itself. So now I want to create a direction, so I can do a little push and pull. So there's another node called volume sample gradient. I think. Volume gradient, yes. So based on density, the original density, so I use the original mesh, original volume, and sample to sample again. So this is going to give me a vector. But I want to normalize this vector. So in case my values are like too big, I don't know, maybe I have a massive volume and it's 2 kilometers wide. You don't want a 2 kilometer wide vector because it's going to be hard to manage. So instead, we normalize it. So we have a normalized value, so it's like 0 to 1. I'm because our distance is from center to the edge, so I want to reverse that now. So I'm going to multiply so I can play with the values, right? So right now, I have a direction and I have a vector. So what I can do now is that I can manipulate. Remember, we were taking our original positions from this guy, so what we can do is that we can try adding, because it's a position, right? It's a vector. So let's delete this. I'm going to plug this guy here, and I'm going to add a multiply constant. I'm going to play with this to see what it does. Okay. So if I go negative, it's going to push my volume towards the center. If I go positive, based on the available bandwidth, I think we need also, don't forget to put the field interior as well. So because if you want to push outwards, you need to extend your voxels more, but right now we're just playing. So we're going to go negative because it's just easier. So if I go down here, so basically let's go maybe 0.5. I think that's going to be too small, but still good. We can move our visibility box closer. Okay. I think we can use a light here, so it kind of gives us a little bit of shading as well. It's not bad, it's not yet, but look at there. Okay, so now let's say I don't want to just uniformly change the distance. So let's go maybe 100 here. I want to maybe use a noise to break up the values of this gradient, right? So let's put in a turbulence noise. And I'm going to plug position to position. So now I want to break up this section. So let's go back to my original CVEX. So look what I'm doing here is that I have a noise and I am multiplying my vectors that comes from volume gradient, and then I'm adding them to the original position. So that's going to break up the even look of the noise. So if I go add, bring it here, plug it in. All right, so we're getting somewhere now. Whoa, I need to hide these cameras so I can focus on my object. Okay, so let's crank up the density a little bit better. Okay, so let's go down to 1,000. All right. So remember, we have a very low resolution now, so let's play with the noise to see what it's doing. So if I increase the noise, let's start getting this nice detailed sections, right? So we can even try different, like anti-alias noise, all these different things. These are just for experimentations for you guys. We really have some nice cloud shapes, right? So you pick your noise type and just plug into the add. And let's say I need to maybe animate something through this, and it's going to be impossible because if I actually have a massive cloud, so if I go like this here, and if I don't have enough resolution, I'm not going to see much. Let's go back to here. But now, because I have a box that I can arrange efficiently, I rotate it instead. If I make it smaller, and I can really focus on some detail areas, because now I can increase my resolution by decreasing the voxel size, and I start getting is amazing detailed volumes. Okay, and the good thing about this is only for display, because if we have, because all this is going to be generated at random time, the only thing the software is going to look is, do I have a density somewhere here? Right now we're using something spherical, so it's not even that important. You could entirely do this at random time. But let's go back to our visibility settings again. Okay. So if you look here, oh, where did my shadows go? Okay. And now I think we can even, let's see what this laptop can do. So let's push it a bit more. Well, how many voxels? This is only 6 million voxels, that's nothing. Let's go a little bit more. Okay, now it's kind of slowing down. I hope the recording is fine. Still fine. Okay. I'm gonna wait for it to calculate because it's really trying hard. Okay, still going. Maybe there it is. Okay. So now how many voxels is this? Okay, it's 100 million. It's not that much. I guess the calculation took a while. So now if I go inside, I can literally say I want more turbulence and executing works. Visualize it. And we can then we're going to increase the roughness a little bit, just to show you that it's very actually simple to create this kind of level of detail. And now when this is basically how the entire concept works. And I'm going to jump into the previous node I made, and this is taking a while because it's too many voxels for my laptop, so let's just bring that up to 2. I guess that should go faster. And the cool thing, like I mentioned, is like, let's just focus on this tiny area. Okay, and then maybe even smaller, smaller here. So yeah, there's voxels. So I'm focusing on entirely on this section. So let's go into flex and then maybe increase the roughness a little bit. Oh, is it too much? Maybe 55. Okay, so like you're getting a lot of detail here. And you can keep going and keep going. So I'm going to move back to my CVX1. So let's delete this one. And I'm going to say use CVX1. And I need to be careful with the density. I think that's when it kind of, when you mess with the resolution and everything, it kind of breaks. So I guess if I now even file save and load a new one, oh no, it's because we changed the size location of our volume. So this was originally here. Let me go somewhere here. Let's make it a bit bigger. Just don't crash your PC or your Mac. Okay. Okay, so let's go back to this guy. Okay, so this is this was my the render that I showed you, the spherical one. So what am I doing with the color here is also interesting. This actually doesn't work, but I'll jump back to that in the actual thing. So what we can do then is that we create a little volume shader called test volume. So we drop in a material builder. It comes like this. So we're going to jump inside. Just dropping a volume shader core here. And it's here, volume shader core. And then a compute lighting, and then just make the wires based on their names, so we can calculate. And then basically I'm importing the color as a vector, and then this needs to be another field, just like velocity or density or temperature or heat. Anything can be used. We will use that in the actual detailed version of the nebula. Then I plug in the density, and you can still use some of these shader settings, and you got yourself a X volume for starters. So if I move the camera somewhere here, and if I hit render, I guess I may need to adjust my mantra settings so my computer doesn't choke the recording. I use all except one. Okay. And if I go X volume test cam, I think that should work. Oh, I have the lights forced. I have a. Oh, we didn't change the bounding box for the geometry. So this needs to be pointing to 1. Let's see render. Let's see what comes up. Well, the other thing with this method is it's not a fast render. It depends on the settings and everything. But I'm going to change a few other things. So I set stars. So basically now we are completely driving the render quality by using the where is the X volume in a mantra settings on the sampling. So the volume step rate is going to give us volume set rate, and the volume quality is going to give us the biggest difference. It also by default this is 0.25 volume step rate. So which means that like for shadowing, take only 1/4 of the voxels that you trace through. So it's like it skips every third one or something. So that's why the thing is, once we increase the quality, it actually gets denser as well. So we need to be careful about that to play with the density versus the quality. So you have to play along with the renderer, so it manages it fine. So if you look here, there's a nice detail on this very simple sphere. All right. So just going to give you a little sneak peek of what we're going to build. So what we're going to do is first we're going to get 2 spheres. We're going to convert them to volume and then collide with each other, so it kind of creates like a little crown. And then we're going to create a pyro simulation out of it using those flip, just to create a bit more random stuff, like because it's like if you observe the nebulas, it's usually they're made out of a lot of filaments, like really dense areas, and then they're really not dense areas. So using this pyro, we're going to eject some particles, and then those particles will be converted to volume together with the pyro, but like a different volume. So like we're going to get 2-3 fields. So we're going to create really dense areas and not dense areas. And finally, we're going to end up creating our nice volume shader. This is not even that complex actually, and then we will end up with. Let me find you the video again, so we can watch it in full glory. Complete. Where is it? Here. And we will end up with our lovely nebula. I have to say that this actually took like only a few days of work. So if you follow these guides very well and understand exactly how the procedure works, you can create amazing images, especially if you have access to a studio farm. They're very beautiful, very easy to create. Okay, I'm going to stop the video for now, and we will continue in our next lesson.